Alright, hello math fans. This is day 4 of chapter 2, and I just want to review what we learned yesterday because we're going to be using quite a bit of that yesterday. We did limit as x approaches 0 of sine of x over x. And remember that equals 1. Okay, and we proved that yesterday. We also did limit as x approaches 0 of cosine of x minus 1 over x, and that equals 0. And then we did limit as x approaches 0 of tangent of x over x, and that equals 1. Okay, so those are pretty important. So let's start out with a problem. Kind of keep that in mind here. Let's start with a problem like this. Limit as x approaches 0 of sine of 4x over x. Alright, well, you can't just you can't just cancel things out. There's nothing to cancel out. It's sine of 4x, right? That's part of the angle. But what I can do is, if you remember, sine of 2x, that was our double angle for sine. That's 2 sine of x cosine of x. So if you think of this, I can actually write this as limit as x approaches 0. Instead of sine of 4x, is sine of 2 times 2x. Alright, so that's my double angle. So what I'm going to do is, I can write this as limit as x approaches 0 of 2 sine of 2x cosine of 2x over x. Alright? Because it's kind of like, it's like theta, like 2 theta, and if I said theta is equal to 2x, then when I break it up and I say 2 sine of theta cosine of theta, I just substitute that back in, 2x for theta. Alright? Now, obviously, I can go one more step here. I could say the limit as x approaches 0, and this guy right here, the sine of 2x, that's 2 sine x cosine of x, and we still have cosine of 2x here, right? It's all multiplication, all over x. And well, the only thing I can really simplify is 4 sine of x cosine of x cosine of 2x. Please don't combine the cosine of x and cosine of 2x. You cannot do that over x. Now this is the deal. I can actually break this up now. I'm going to kind of, just so I have the room here, I'm going to break this up and rewrite over here. That's really the limit as x approaches 0 of 4 times the limit as x approaches 0 of sine of x over x times, so I've taken this part, I've taken this part, and then times limit as x approaches 0 of cosine of x cosine of 2x. Alright? Now, I could have actually just taken the 4 out because, remember, with the constant multiple, you can just pull that out if you want. But that's okay. Limit as x approaches 0 of 4 is 4. Limit of as x approaches 0 of sine of x over x. Yeah, there we go. That's our first one up there. That's equal to 1. And how do you do this? How do you do limit as x approaches 0 of cosine of x cosine of 2x? Do I need to do double angle for cosine of 2x? Well, actually, you don't, because remember, you can do direct substitution. I mean, this one's really nice because there's no, I already dealt with my denominator of x. I can just do direct substitution. So it's really times cosine of 0 times cosine of 2 times 0. Okay, and then you remember cosine of 0 is 1. So it's really 4 times 1 times 1 times 1, and we get an answer of 4. Alright, so that's kind of a complicated way to do it. So let's think of a better way to do it. And this is kind of a nice generic formula here. So let's actually delete this here. And the nice generic formula is limit as x approaches 0 of sine of n x over nx. So basically, if you pull that out, the answer before was 4, this is equal to 1. So we're going to do a couple examples that actually kind of show this a little bit. But as long as you have the same number here and the same number here, that's equal to 1. It's pretty nice. So if I said the limit as x approaches 0 of sine of 7x over 7x, that's equal to 1. It's not 7, it's equal to 1. Now I know you're saying, well, wait a second, that last problem you did, that was equal to 4. Well, this is the deal. So let's actually just show that problem. It's limit as x approaches 0 of sine of 4x over x. That was our original problem from before. So this is the deal. I'm going to put a 4 here because sine of 4x over 4x is 1, but I got to balance it. Right? It's like 4 over 4, which is 1. That's fine. Well, I can take this out. It's just a constant multiple. So that's equal to 4 times the limit as x approaches 0 of sine of 4x over 4x. Pretty sweet, because now that limit goes to 1, and it's 4 times 1 is 4. So that's exactly the same answer as we did before. Okay? So that's what you want to do. Let's try it on, well, we can do another one here. Limit as x approaches 0 of sine of x over 3x. Now that's actually even easier, because really, again, you're kind of looking at this sine of something x. Okay, it's sine of 1x, so I just need to get this to be a 1x on the bottom. So it's like saying 1/3 here, right? 1 over 3. So I can rewrite this as limit, or actually 1/3. I'm going to pull the 1/3 out. Right, here's a 1/3 right here. 1/3 limit as x approaches 0 of sine of x over x. And that's sine of x over x is 1, so the answer is 1/3. Okay, so let's try another example. Limit as x approaches 0 of sine squared of x over x. All right, well, again, I'm looking for, when you have this x on the bottom, math fans, you got to deal with that by knowing that nice limit as x approaches 0 of sine of x over x. That's the way you deal with it. And then hopefully that denominator then goes away. So I can actually rewrite this as limit as x approaches 0 of sine of x over x. Okay, there you go. That's a nice part of it. Now you got to keep writing that limit, but you can write it as a multiplication now, because just by the product property you can pull it apart. So it's limit as x approaches 0 of sine of x times limit as x approaches 0 of sine of x over x. And I can do direct substitution to that, because there's no denominator that's going to go to 0. So sine of 0 is 0 times 1. So the answer to this problem is 0. All right. Let's do another example. Limit as x approaches 0 of 5 minus 5 cosine of x over x. Okay, again, you should kind of think back with cosine, right? We had that nice one, cosine of x minus 1 over x. Well, it's not really quite in that form, but what I can do is I can rewrite it. Limit as x approaches 0, and I'm going to turn it around and I'm going to factor out a negative 5. Because if I turn it around, then I get cosine of x minus 1 over x. Right? Is that okay? I hope that's okay for everybody. I can't really tell because I can't quite see you from this video. But again, here we are. We're going to pull that negative 5 out, so it's equal to negative 5 times the limit as x approaches 0 of cosine of x minus 1 over x. And cosine of x minus 1 over x equals 0, so it's negative 5 times 0 is negative 5. All right. We can actually do the same thing as we're doing with sine. We can do that with tangent. Limit as x approaches 0 of tangent of 5x over x equals, again, I want to put a 5 in the bottom there, so it's, I'm just going to kind of show it a little faster way, 5 times the limit as x approaches 0 of tangent of 5x over 5. Now remember, I didn't change the problem at all, because if I would put that 5 back in there, right, 5 over 5 is 1, so I didn't change, oops, I need the x. I didn't change it at all. Okay, so I get 5 times tangent of 5x over 5x is equal to 1, so my answer is 5. All right, not bad. Okay, so that's basically the ones with sine, cosine, and tangent. Let's do some other algebraic ones. Okay, if I have the limit as x approaches 0 of the square root of x plus 7 minus the square root of 7 over x. Well, again, you cannot just do this problem with direct substitution because you have a denominator of 0. So the way you get rid of this, and if you kind of think about it, when you see a bunch of radicals and it's added and subtracted, you guys almost should think of that you need to do something with a conjugate, and that's exactly what you're doing. Now, most of you are used to doing something with a conjugate when it's on the bottom, but it's on top now. But that's no big deal, because watch. So I'm going to multiply this by the square root of x plus 7 plus the square root of 7 over the square root of x plus 7 plus the square root of 7. So I get limit as x approaches 0. Okay, if I FOIL it, I get x plus 7. Outside and inside cancel, and then it's minus 7. And on the bottom, I'm not going to, even though it's tempting to distribute that, I'm not going to do that. So radical, or x times radical x plus 7 plus radical 7. Okay, so I get limit as x approaches 0. They cancel, and I just get x over x times square root of x plus 7 plus square root of 7. Now the beauty of this is the x's cancel, and I wind up just getting limit as x approaches 0 of 1 over the square root of x plus 7 plus square root of 7. Okay, well, now I can do direct substitution because I don't have a 0 on the bottom anymore, so that is equal to 1 over square root of 7 plus square root of 7, which is 1 over 2 square root of 7. Rationalize, I get root 7 over 14. Okay, that's your answer. Now, if you did this on your graphing calculator and you, again, you did a value, what is it getting closer and closer and closer to on your calculator, you couldn't do a direct substitution with the way it's written, but you can, plug something in, 0.00001 and negative 0.0001, and they would both give you something close to that answer. In fact, your graphing calculator would give you 0.18898. All right. Okay. So let's talk about the integer function. Okay. So f of x equals the integer of x. Now, if you guys can, I don't know if anybody can remember what the integer function is, but an integer function just means if I take, let's say, the integer of 1, that's 1. The integer of 1.9, that's 1. The integer of 1.999999999, that's equal to 1. So basically what you're doing is you're truncating the decimal. That's what it does. It's taking the integer part of the answer. So, and then of course if I go to integer of 2, that's 2, integer of 2.00001, 2, just to give you an idea, okay? So if I would actually graph that, it would look something like this. Now this is the deal. Well, let's put a couple of lines here. You know it's going to be, I'll use a different color. Okay, so here it's that, and it's there, and it's a step function. You guys recognize that? Now the deal is, where do you put the open circle and where do you put the closed circle? Okay, well think about it. If the integer of 1 is 1, that means it's got to be a closed circle here. And as soon as you get to 2, which is right at this point right here, it jumps up. Okay, so it's an open circle here and another closed circle. So open circle, closed circle, open circle. So this is going to be an open circle, closed circle, etc. That's the look of it. Okay. All right. So let's do a limit here now. If I do the limit as x approaches 1 from the positive side. Okay, so if I label 1, 2, 3, 4, so it's approaching 1 from the positive side. That means I'm on this line here at on the 1. You guys agree with that? Let's see, let me write the function here. So the answer to that one would be 1 because I'm right here. I'm approaching it, and I'm still on the 1. Okay, what about the limit as x approaches 1 from the negative side? Well, here I am from the negative side. I'm at 0, right? I'm at 0, so that's equal to 0. So the limit as x approaches 1, remember it's a two-sided limit, and they're not the same, so it does not exist. Okay, what about the limit as x approaches 1.001? What's that equal to? All right, because it's a two-sided limit. But that's not on, it's not where it's a critical point where it's jumping from one value to another. So that's equal to 1.001. You know, anything. I could say limit as x approaches 1.5. It's 1.5. But as soon as you're on something where it jumps, like here or here or here, right, any place where it's an open circle and a closed circle, that limit is not going to exist for this integer function. All right. Okay, so one more example. If I give you the limit as x approaches 2 of x squared minus 3x minus 2 over x plus 2. All right, so what are we going to do here? Probably try and factor, cancel things out. And so how do you factor the top? What is the top factor? 2x and x and minus 2 and plus 1. Well, that's not going to give us negative 3. It's interesting. So I guess we can use the quadratic formula. You guys all remember that? But the real trick is, math fans, is remember, if you can substitute directly into the equation with, and it's not going to give you an undefined answer, or, you know, it's not a piecewise function, but if you can directly substitute into that, then you want to do that. And it's a little tricky because if I had said negative 2, you got an issue. Okay, but I'm saying as x approaches positive 2, and I can have 2 in the bottom. So this limit is just saying 2 squared minus 3 times 2 minus 2 over 2 plus 2. So you get 4 minus 6 minus 2 over 4, or 4 minus 6, negative 2, negative 4 over 4. The answer is negative 1 for that problem. So that's actually easy, but be careful that if you can do direct substitution, do it. If you can't, then you need to manipulate things in order to allow you to substitute something in. So that's what that limit is. Okay, so I have one more example to do with you guys. Limit as x approaches 0, and this is a nice little rational problem here. 1 over x plus 6 minus 1/6 over x. So again, remember guys, your goal is to get rid of that x in the bottom, okay, because you can't do direct substitution unless it's defined, right? So what I'm going to do is I'm just going to get rid of these fractions. I'm going to multiply by my LCD, which is to get rid of that x plus 6 and that 6. I'm going to multiply by 6 times x plus 6 over 6 times x plus 6. Okay, if I do that, I get limit x approaches 0, and I'm going to get 6, right? And then the next one I'm going to get minus x plus 6. And the bottom I'm going to get x, well actually 6x times x plus 6. You don't want to distribute that bottom, okay, because if you do that, it's not going to look pretty here. So we're going to do limit as x approaches 0. It's going to be 6 minus x minus 6, so I basically just get negative x. In the bottom I get 6x, x plus 6. Okay, the x's cancel. So I really get negative 1 over 6x plus 6. Now I can do direct substitution because I don't have that x anymore. That was our key, to get rid of that x. This x is okay because I'm going to add 6 to it. So I wind up getting, with direct substitution, negative 1 over 6 times 0 plus 6, or negative 1 over 6 times 6, which is 36. And that's it. Okay? Pretty easy. A lot of different types of problems, but it's just a matter of manipulating it so you can do direct substitution. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.